Okay, this is the gold packet. This is page 3, and it says example 2, cookies for class. Talked about in this class, if this was one of my kids, I would be really, really cranky with him. It says Brandon came home from school and informed his mother he had volunteered to make cookies for the entire grade level. And he needs 3 cookies for each of the 96 students in the 7th grade. Unfortunately, he needs cookies very next day, and Brandon and his mother determined that they could fit 36 cookies on 2 cookie sheets. So I'm looking back here, dear Brandon, well, luckily he doesn't go to a very big school like Davidson Middle School. He's got 96 students in his 7th grade class. We have like over 400. So just thinking 3 cookies for each of those 96 students. How many cookies are they going to be making? 3 times 96. Oh my goodness, 288 cookies they're going to need. And he and his mom have determined that if they would take a cookie sheet, like there's, cookie sheets are those pans that you put the cookies on, like 36 cookies will fit on these 2 cookie sheets. Not 36 here and 36 here, but 36 cookies on those 2 cookie sheets. So letter A says, is the number of cookies proportional to the number of cookie sheets? So cookies proportional to the cookie sheets. Create a table that shows the data for the sheets and the total number of cookies. Okay, so we've seen a lot of different tables. You know that you could have tables that go like up, down like this, and you can have your headings here, or you could have your table going across with your headings right here. It's up to you. I'm going to make my table with, let's see, we were looking at the number of cookie sheets needed and the number of cookies. So I'm going to put number of sheets and the total cookies. And there's really not one right way to go about making this table. I saw a variety of them when we were working in them in class. It is helpful to start with this first piece of information that we have here, and that if there are 2 cookie sheets, there are 36 cookies. A lot of kids just kind of wanted to follow a pattern, which a table does not have to follow a pattern, but they chose to say, all right, well, we're going to double the cookie sheets, and if you double the cookie sheets, you have to take the number of cookies and double that, so that would be 72. And then they kept going with that, and they said, okay, now I'm going to have 6 cookie sheets, so 2 more cookie sheets is going to give me 36 more cookies. So we'd be at 108, and then 8 cookie sheets would be 36 more, so that'd be 144, and they just kept it going. Whoops, 144 plus 36 is 180. And then I'm going to move over here to this side because I'm kind of running out of room. A sideways table would have been good here. 12, let's see, 180 plus 36 more would be 216. And then 14 cookie sheets would be 36 more cookies, 252. 16 cookie sheets would be 36 more cookies. Oh my gosh, right there. I'm at 288 cookies, which is exactly what we needed. Like I said, this is not the only way to go about it. Some kids realize that if you had 1 cookie sheet, that would be 18 cookies. And they were then able to go, wow, I can just take whatever number of cookie sheets I have, and I'm multiplying that by 18. And so I'm just going to put dot, dot, dot. So is the number of cookies proportional to the number of cookie sheets? We would definitely have to say yes. Cookies are proportional to the sheets because there's a common, and you have multiple things that you could say here, common unit rate, the common multiplier. You can even use our new term that we're starting to use more now, and that's the, that's the constant of proportionality. Moving on to letter B now, the unit rate for this particular problem, it says a unit rate of y over x. We don't have any y over x or y and x information here. but from, again, using science, thinking about which ones you're independent and which ones you're dependent, your number of cookies, your total cookies, is going to depend on the number of cookie sheets that you're using. So this is your dependent, so that's your y. This is your independent, that's your x. So anytime you're taking these y values, like 36, putting it over 2, or 72 and putting it over 4, those are coming out to 18. 72 divided by 4. 8. Whoops, sorry, I put the wrong thing in there. 72 divided by 4, coming out to 18. So the unit rate is 18. And we also know that the constant proportionality is the same as the unit rate. They're the same exact thing. So that is also, I'm just going to say k equals 18. And with letter D, it says to explain the meaning of the constant of proportionality in this problem. Explain the meaning of that COP in this problem. This problem is all about the cookies and the cookie sheets. So we have to explain what that 18 is. It's 18 cookies per sheet. And then moving on to letter E here, it takes 2 hours to bake 8 sheets of cookies. Brandon and his mother began baking at 4:00 p.m. When would they finish? So we know that they're going to need, we need 16 sheets of cookies. And here it says that it would take, to get 8 sheets of cookies, it's going to take 2 hours. So if we need 16 sheets of cookies, that's twice as much. So it would clearly take twice as long, and that would be 4 hours. I'm just checking back here to see what I was asked. When will they finish? So 4 hours after 4 o'clock, plus 4 hours more. That's going to be 8 o'clock p.m. that they finish.